Hi everyone, welcome to Basic Chemistry. Now I am discussing a physical chemistry unit, photochemistry. Here, the textbook is Principles of Physical Chemistry, that is Puri Sharma Patania textbook, and the chapter is photochemistry. That is a 29th chapter. Okay, 29th chapter, that is photochemistry. So I think you heard about a photochemistry. What is photochemistry? Photo means light, right? So photochemistry deals with the study of chemical reactions which are caused by the absorption of light radiations. That is light radiation, we can call it as a photons. Okay, only the absorbed radiation can cause a chemical change, that is the light radiation of the visible and ultraviolet regions. And we know that visible and ultraviolet regions are lying between 800 nanometer to 200 nanometer wavelength. Okay, so actually photochemistry deals with the absorption of light radiations in the visible and UV regions. Okay, so there are different types of photochemical reactions are present. We heard about thermal reactions. What is the difference between thermal reactions and photochemical reactions? In ordinary thermal reactions, the activation energy result from the random intermolecular collisions. That is the thermal reactions. There is an intermolecular collisions between the particles. Okay, whereas in photochemical reactions, the activation energy is acquired by the absorption of photons of light and associated with a particular amount of energy. Okay, here by using a monochromatic light of a particular wavelength in the visible or ultraviolet region. Okay, and thermal reaction, there is a random intermolecular collision, whereas photochemical reaction means selective absorptions. That is, here it is absorbed the wavelength from the visible and ultraviolet region only. It is possible to excite a particular atom or a molecule in a mixture instantaneously to an excited state. But in a thermal reaction, it is not only selection, it absorbs heat and it all the atoms or all the particle get excited. Okay. Thus, a photochemical reaction only a single selected species, atoms or molecules can be promoted to an excited state, independent of the other species present in the reactions. Whereas thermal reactions do not permit such selectivity. So, one of the example, for example, exposure of a mixture of hydrogen and bromine to radiations of wavelength between 415 to 550 nanometer. Okay, the excitation only bromine molecules. So that is a photochemical reactions, because we know that the range is uh, near to the UV and visible range. So the excitation only the bromine molecule. So that is a selective. Single selected species can be promoted to an excited independent of the other species present. Okay. Whereas in the exposure to thermal radiation, that is heat, would cause excitation of both the bromine and hydrogen molecules. So that is a major difference between thermal reactions and photochemical reactions. And there are different applications. Most of the powerful tools in research, that is photochemistry, is a very good application. Synthesis of complex molecules such as proteins and nucleic acid occurs through photochemical reaction between simple gaseous molecules as carbon dioxide, ammonia, and methane. We know the formation of vitamin D, the formation of ozone from oxygen in the Earth's stratosphere, formation of smoke, and unfortunate development of skin cancer. Also, the demerits of this uh, reaction, that is that is the development of skin cancer, are important examples of photochemical reactions. So here also reaction will be takes place. Okay, a new field of research, that is photobiology. It's very important nowadays. It's very important in the research methodology. There is a photobiology has emerged recently. Actually, it deals with the photochemistry of biological reactions and helped to a great deals in partly understanding the mechanism of photosynthesis and other complex biological phenomena. Okay, so there are other reactions, that is organic compounds such as vitamin D2, cubines. Cubines mean anti viral agents. Okay, caprolactam, monomer of nylon, and several insecticides and cleaning solvents have also been synthesized photochemically. And photochemical materials which have a peculiar properties of changing color when exposed to radiation of suitable wavelength, and also it can be prepared from by using the photochemical reactions. Okay, then absorptions of characteristics withdrawing the incident radiations, and other examples of spiropyrens belong to the class of photochemical materials. They are used to photochromic sunglasses. They have also been used in the production of information storage and self developing